ionization energy and its periodicity. So this topic is new to you, that what does mean by the ionization energy. So let's have a look on the ionization energy. Basically, ionization mean to ionize. Now we are going to ionize the atom. So by definition, ionization energy is the minimum amount of energy required. It is the minimum amount of energy required, and this energy is required to remove the electron remove the electron from outermost shell outermost shell of an atom to make a ion positive ion. We need to provide the energy to the atom. That energy is known as ionization energy. For example, we have an atom A and we want to remove the electron from its valence shell. Like this, it is having two electron in the first shell, and the last shell it is having one electron, and we want to remove this electron from this atom, so we need to provide energy. This energy that we are going to provide, it is known as ionization energy. Next, after the removal of this electron, it will be changes into the cation like this, +1. If we are going to remove one electron, then it will carry the charge +1. So this is the ionization energy, the minimum amount of energy required to remove the electron from the outermost shell of an atom to form a positive ion. So let's discuss more examples to clear this concept of ionization energy. For example, the first ionization energy of sodium. If we are talking about the sodium, its atomic number is 11. Its electronic structure is like this: plus first shell is having two electrons, the second shell is having 8 electrons, and the last one shell is having one electron. So we want to remove this electron. To remove this electron, we have to provide energy to this atom. So that energy is known as ionization energy. For example, after the removal of electron, we are going to provide energy to the sodium atom. After providing the energy, this electron will be removed from its outermost shell, and the sodium will be changed as sodium ion, and it will carry the charge +1 and +1 electron that has been removed from the sodium. And the first ionization energy of the sodium is plus 496 kilojoule per mole. The plus sign is showing that this process is endothermic. Endothermic mean we are going to provide energy, or the energy will be absorbed in this reaction. So this is showing the endothermic reaction, and to remove the valence electron from the sodium atom, we need 496 kilojoules of energy to, to have this reaction, or for the ionization of the sodium. Similarly, we have the second example for magnesium. It is in the gas form. Next, we will provide energy. After providing the energy, we will get magnesium +1 and +1 electron. As magnesium is having two electrons in its valence shell, so its second ionization energy will be like this: magnesium +1. We want to remove the second electron, so by providing energy to the magnesium, we will get magnesium +2 and the +1 electron. Its first ionization energy will be almost 738 kilojoule per mole, and its second ionization energy will be plus 1450 kilojoule per mole. So this is a simple example related to the ionization of energy. The simple we need to remove the electron from the valence shell of an atom of an element, we need to provide the energy to the atom. That energy is known as ionization energy. Okay, next we have the trend of ionization energy, or the factors affecting the ionization energy. There are a lot of factors that affect the ionization energy. The first one we have nuclear charge. Second, we have shielding effect. We have atomic size, and the fourth one we have electronic configuration. So these four factors affect the ionization energy. We will discuss these factors in our next video, but we have to discuss the more related topic to the ionization energy is trend of ionization energy along periods. Periods are from left to right in the periodic table. When we move from left to right in the periodic table, there is a increase in the ionization energy. As the periods, there are total 7 periods in the periodic table. The ionization energy is going to increase. Ionization energy is going to increase from left to right. And what is the reason behind that? The ionization energy is going to increase from left to right. For example, we have hydrogen and helium. After that, we have lithium to neon, and we have from sodium to argon. When we move from left to right, the nuclear charge is going to increase. Nuclear charge is going to increase. Nuclear charge means the positive charge is going to increase in the nucleus. Now, this positive charge will pull the electrons more tightly, more forcefully or tightly. So we need to provide more energy to remove the electron from the valence shell. Likewise, if we are talking about the lithium, its electronic structure is like this. First shell is having 2 electrons and the last shell is having 1 electron. And to neon, it is having first shell 2 electrons, last shell it is having total 8 electrons, and between we have the fluorine and chlorine. So fluorine, it is having 2 electrons in the valence shell, and next it is having 7 electrons in its outermost shell. It is having only one in the valence shell, along with number of protons in it is 3, and in it the number of protons is 9. So higher the number of protons will pull the valence electron towards itself more tightly. In turn, we have to provide more energy to remove the electron. So that's why when we move from left to right, ionization energy increases. On the other hand, trend of ionization energy across groups. When we move from top to bottom, the trend of ionization energy that it is going to decrease. And why it is going to decrease? For example, the hydrogen, it is having only one shell. The second we have lithium, it is having 2 shells. Next we have sodium, it is having total 3 shells. And after we have potassium, it is having total 4 shells. So from top to bottom there is increase in number of shells. When the shells are going to increase, it means the valence electron are going away from the nucleus. So there is less force of attraction between the nucleus and the valence electrons. When there is a less pull between this, so we have to provide less energy to remove the electrons. So that's why ionization energy is going to decrease from top to bottom in the groups. I hope you guys understand about the trend of ionization energy in groups as well as in pairs, and what does mean by ionization, that is related to the different examples. And if you guys have any queries, you can ask me about that in the comment section, and if You have any confusion, you can also ask that. For that time, have a good day and Allah Hafiz.